Welcome to the Helix webinar series. Today's session is on aligning sustainability goals with green IT practices. We're fortunate to be joined by Michelangelo from the Solutions Engineering team. He will give his formal introduction very shortly. For now, you will remain muted. We've got quite a lot to cover through the presentation and demo. I'm just going to remind you that there is the Q&A section of Zoom, which you'll find at the bottom. If you do have any questions, please put it into the Q&A chat section, and we will come to the live questions towards the end. We did have quite a few questions this morning, so hopefully you've got some questions as we go through the presentation and demo. We've also got Yaron that's going to be supporting us on the panel if there's any further questions. So Michelangelo, I'm now going to hand over to you to get you started.
Yeah, thank you, Samantha. So my name is Michelangelo Gioia, and I'm a principal solution engineer at BMC Software. So today we'll explore how BMC technology can support ESG goals and reduce environmental impacts and drive positive change within and behind the business. So we will start now the webinar, and so I just introduced the green IT trend. So the future of IT is just about innovation, it's about sustainability. And sustainability has become the second highest priority for corporations after profitability. Key trends show that by this year, starting from this year, after CIOs will have their performance metrics tied to the IT sustainability. However, there are some challenges that they are facing now. Without sustainable action practices, in fact, the artificial intelligence is projected to consume more energy than the human workforce. And this is a big problem because this is negating the carbon zero initiatives. Aligned to the 2030 agenda, we need to reduce emission by 55% compared to the 1990 levels to achieve climate neutrality by 2050. So this is where green IT comes in. It's about delivering technology with a positive environmental and social impact. It's not just obviously reducing carbon footprint, but also about how we are able to use technology to solve global changes like climate change, poverty, and inequality. So the green IT has a more and more other topics that touch in the space of the sustainability. So in this webinar, I will share a real-world example of how to achieve sustainability goals, and we will start to talking about a real implementation that I did in a customer. So this customer is an assurance and financial services companies needed to optimize IT resources to reduce carbon emission and cut costs. So among the company's objectives, in fact, is to achieve carbon neutrality within 5 years. So they will start, they already started the last year, and they are now evaluating to improve the actual installation in order to achieve this goal. So by leveraging predictive analytics and proactive resource planning, they will reduce infrastructure inefficiencies, minimize operating costs, and support their ESG initiatives. So this case highlights the tangible benefit of integrated sustainability into IT operations, and in particular, the importance to have in place a structured capacity management process that we will see is the key for the success of in this case, of this ESG initiative. So data centers, we are talking about the IT, and obviously data center plays a key role in IT operations, but are among the most energy intensive facilities. You have to imagine that the data center consumes up to 50 times the energy of a typical office buildings. So the emission can be categorized into 3 scopes. Direct emission due to on-site generators, this is the scope 1. Indirect emissions from the operational phases due to the energy consumption, scope 2. And emission related to the supply chain and disposal, this is the scope 3. So understanding these scopes is crucial to delivering effective strategies for energy efficiency and carbon footprint reduction. So in our case, and in the case that we will see later in a demo, so we focus on the indirect emissions, so scope 2, depending on the energy use. Therefore, strictly related to the usage of IT resources, such as servers, storage, box, and network devices mainly. So we supported our clients with BMC Helix continuous optimization. So a BMC solution that helps to reduce energy costs and carbon emission by optimizing the use of IT resources. And so we started with three key initiatives. One is the first one was the resource optimization. So with the smaller distance sizes, we achieve lower energy consumption, paving the way for a sustainable IT strategy. The second is the workload consolidation that minimizes the hardware needs, reducing electricity and cooling requirement. So basically, the ability to run the same workload but using less hardware. And then, third initiative is the breaking down carbon emission by data center, region, and application. Why this? Because this transparency allows you to identify high energies consuming areas, enabling better decision making. So this is why it's important also to have to know how the carbon emission, the total carbon emission, is composed. So now, what influence carbon footprint and energy use? So several factors affect the carbon footprint and the energy used. So static and dynamic factor. So static factor that include hardware models, geographical carbon intensity, and PUE, power usage effectiveness of data center. This is an indicator that show you how much is efficient data center to use and consume the energy. And then dynamic factors like the consumption of computational resources over time. Let me say that dynamic factors are also the most interesting factors because their analysis provide actionable insights. And we will see that we can correlate all the information with dynamics factor in order to estimate and to generate also recommendation to better right-size the infrastructure and reduce the carbon footprint. So by understanding and addressing these variables, companies can significantly reduce their carbon footprint and their carbon impact. So we are talking about the operation, and as I told you before, so we are focusing on indirect emission due to the energy consumption. So our impact depends on the energy that we use, okay? And the carbon intensity is a measure of how clean our electricity is. So basically, it refers to how many grams of carbon dioxide, so CO2, are released to produce 1 kilowatt hour of electricity. This is the main reason why the electricity generated, for instance, using fossil fuel, is carbon intensive, as the process by which it is generated creates carbon emissions. At the contrary, renewable energy sources such as wind, hydroelectric, or solar wind produce almost CO2 emissions. So the carbon intensity value is much lower and sometimes is really close to the zero. So if we want to understand our environmental impact of electricity use, we can find a lot of information using electricity maps. So those maps provide information about the carbon intensity of electricity generation in various regions of the world. Green countries that you see in this example, which use more renewable sources, produce cleaner energy. So this means that identical data centers have different impacts depending on the country that they are located in, just by looking at the electricity they use. And this is really important because we will see in the real case that also this information drive key initiative for the company in order to modernize data center or move and change the equipment or the hardware inside the data center itself. So I want just to remember before to go ahead that the presentation will be available after the webinar. So all the links that you find in the slides will be accessible as well. Okay, so you don't need to take pictures and screenshot or take note about the links or other information. So looking at the AT resources, several studies has validated that power consumption depends mainly on CPU usage, and that there is a linear correlation that varies between a limit value, that is called the idle power, which indicates the power needed to keep the hardware on, and the maximum value of the power consumed when the CPU is used at the full load. So uh, this means that it's very important to properly sizing and configure the resources is essential because these allow you to reduce energy waste and consequently also give you the opportunity to reduce and improve the carbon footprint. So this linearity and this study is also true in the cloud. In fact, you see here an example of carbon emission datasheet for an AWS C2 instance. So as we saw before, the carbon emission is related to the CPU usage, and you can see that also here the linear correlation still valid also for the cloud. This is just an example, but we can use the same model also for the storage and network devices, obviously with different metrics that we have to consider. We have obviously the CPU, like a key metric, but for instance, in the storage, we have to consider also the throughput of the storage or the traffic that the storage and the read and write intensity of the storage devices. In the network, when the network is virtualized, we can compare the same that we do in the server using CPU utilization. Otherwise, we can take also here the throughput and not only the CPU like a metric to consider in order to estimate the carbon footprint emission. So now I introduce all the ingredients that we need to properly calculate the carbon footprint. So let me walk through how we can calculate the carbon footprint of IT operation using BMC Helix continuous optimization solution. So to start, we leverage the three key data inputs: carbon intensity by country, power consumption. This information can be directly integrated from data center infrastructure management tools that are usually tools used to manage the facility in the data center, or otherwise can be also estimated based on the equipment and the workload profiles of the hardware. So for instance, in this example, that in this customer, not all information can be collected directly from these same tools, but we also derived power consumption using also spec int of the hardware where the data was not available. And then the third input is the power cost by country. Obviously, this is important if you want also to estimate the power cost that you are sustained and understand also and forecast the expenses to the year, okay, to understand the total amount of expensing that you are supporting now in your IT infrastructure. So using this input, we compute two essential metrics. So we are able to calculate the carbon footprint and the electricity expenses. So the results then are broken down into carbon emission by application and business services, enabling detailed visibility. These allow organizations to pinpoint high impact areas, optimize resource usage, and make more informed decisions to reduce both emissions and cost effectively. Okay, so this holistic approach at the end not only reduce environmental impact but also drive cost saving. So let me say that we will start to reduce the waste in resource consumption, and this work directly affect also the reduction in the carbon emission and obviously in the cost of IT. So let's jump now directly in the solution demo, so in the reality, and we will see the dashboard that we created in this customer. So this is the first page of the dashboard. This is an overview page and show above some information about all the data centers that customer is managing today. So they have 6 data centers. This is the monthly energy consumption, the total amount of energy consumed from all the 6 data centers, the monthly energy cost, the CO2 emission over the last 30 days, and some important notes about the volume. So in this first page, you see only physical server and virtual machine, but we are working now to extend other parameters and to put here also information about storage and network devices. And then we calculated also 2 indicators that show the energy consumed by server. This is an average, obviously, considering all the consumption in the data center, and the CO2 emission by the server. So we know, and we have this average value also for reporting users that company need to produce every year in order to show the progress that is doing in their ESG initiative. So in the map, we represent for each data center in each country, you see different circle with different colors. So basically, bigger is the circle, and measure is the carbon intensity, the carbon emission that the data center is producing. As you can see here, we have region like country like Romania or Italy or Germany that are that have a big carbon production, carbon emissions compared to the France and Spain. So this map is also represented in the data in the table. So in this table, we represent monthly data for each data center. And you can see one of the first things that you can observe is that the Romania or Italy that are not the bigger data center of this customer produce more emission compared to the France and Spain. In this case, France and Spain are the bigger data center that customer is managing. And this is incredible to see this. So for the reason that I told before, okay? So if we have a different carbon intensity, we are saying that we are using energy that is not so clean. So this means that data center that are able to use cleaner energy automatically can also reduce and can have ESG ranking lower than the other data center. So in this case, this table is very useful to the customer because they can consider, for instance, which is the data center that is producing more emission. And in this case, that can investigate why is happening. Is due to only because they are consuming energy, or they have to modernize the data center, or they can also start initiative to dismiss or to refresh the hardware. All these things can be evaluated only if you have a clear visibility about how the data center is producing carbon emissions. Or otherwise, another interesting initiative that this customer is starting is want to deploy new application, but they want to move a part of data center in data center that are more efficient. So in this case, the idea is to balance and to have more or less at least the same carbon emission value for all the 6 data centers. So this means that data centers that are producing more carbon emission probably will be modernized, and part of the data center will be dismissed, preferring data center that use cleaner energy than the other. Above in the page, you can see a table that shows the top 10 business services in this case, and we estimated the carbon emission for each business services. So this is possible because we integrated their CMDB. In their CMDB, they have all the catalog about the business services and application. And we grouped all the, in this case, the servers belongs to the business services. And we calculated for each business service the carbon emission that they are producing. Obviously, this value depends from the location where the server is running, and also from the carbon intensity of the location itself, and how they are using also the CPU and other resources. Also in this case, you can see that, for instance, if you consider the first business service and the second business services, and you try to compare these two business services, you can see that you have more or less the same amount of virtual machines on the same in terms of resources, but at the end, the second is producing less carbon emission. Also, if the utilization of the CPU is more or less the same. This is why the stock trading is mainly based in Romania. So also here, the indicator of the carbon intensity is very important to calculate and to better estimate the carbon intensity, also at the business and application level. We use also the correlation between the CPU utilization and the power consumption in order to estimate, based on the recommendation that Helix continuous optimization is able to automatically generate. We estimated how many CPU can be reclaimed, and in this case, how this can bring value in emission, CO2 emission reduction, and in absolute value and in percentage. So basically, Helix continuous optimization, and we will see later in the other page, is able to generate recommendation. And we use the correlation between CPU utilization and power consumption in order to estimate how the carbon emission could change if we are able to optimize and right-sizing better the usage of the CPU and also the other resources. Obviously, you can drill down in each business services. You can see the list of the servers, and for each server, you can calculate the carbon intensity and the carbon emission. So at the end, the atomic part of this job is the server or the active resources. And I want to show you here detailed virtual machine information that we were able to collect. Okay, so also here we collect and we integrated some information directly from this DUCMDB, and you can see here also we are able to understand this virtual machine is used in Spain from the innovation team. So in this company, they have different data hub that can be assimilated to software factory, let me say. So which is the instance type, the availability zone. In this case, this is a virtual machine that is hosted in the Amazon cloud. So we did this exercise not only with the on-premise staff, but only with resources that are hosted in the cloud. We also studied the environment, and this is important for customer to have visibility about the environment and the role, because in this case, customer is able also to aggregate the data easily in order to understand all the carbon emission produced, generated from production resources, and also all carbon emission produced for non-production resources. And they can decide to run two different initiatives in order to be more aggressive in right sizing of no production resources, for instance. So we calculate carbon footprint from running. So this is the carbon emission produced from the virtual machine when it's running. And we also introduce another information because, let me say, it's easier in some cases, in this case in the cloud, to collect also this information because there are a lot of companies that are working with the cloud provider in order to formalize this data and provide public information about the carbon emission. This is the data about the manufacturing of the virtual machine. So this is the scope 3. If you remember, we have different scope, and then we can categorize the carbon emission in different scope. The scope 3, this represent this, okay? So all the carbon emission related to the supply chain and the disposal of the resources. We know that we are able to calculate the cost for monthly cost and the hourly cost for the utilization of the virtual machine. And we are able to estimate the power consumption. So in this case, we can estimate using the CPU, otherwise we can also collect directly from a DSIMS tools the full consumption at the physical level, and then we can break down for all virtual machine the quota part that we want to consider for the power consumption. And then using the energy cost that we integrated, so we estimated and we calculated also the monthly energy cost for this virtual machine. So in this case, customer is able to see, okay, so this is my monthly cost, and this is part of the cost that I'm sustained for the energy. This is the recommendation. So in this case, the machine learning engine behind in the background, considering the fact that it's possible, found it possible to optimize the virtual machine. So basically, in this case, the recommendation is to right size in this virtual machine, change from 4 CPU to 2 CPU and 16 gigabytes of memory to 8 gigabytes of memory. And then we can reduce also the storage based on the recommendation. And is able also to estimate the possible saving. So in this case, it's at $92 per month. So this recommendation is generated automatically from Helix continuous optimization, and the recommendation can be also configured with different algorithms or considering different metrics. So this is, in this case, this recommendation has been generated automatically using the out-of-the-box algorithm and metrics important inside the continuous optimization. Then for each virtual machine, we are able also to show a forecast model in order to understand the future carbon emission. So in the purple line show you the actual carbon emissions up to date, and the yellow line is the projection in the future of the carbon emission. So what we are working today with the customer is also to include this model and this job that we did at this customer also in the solution in Helix continuous optimization in order to estimate based on the recommendation also the benefit that we can achieve in terms of carbon emission and power consumption, so power reduction. So just to show you also the full view. So this is, you can see here, so this is the carbon emission, and this is the actual behavior, and this is the forecasted behavior for the next 30 days. Okay. In this other chart, you can also see and you have information about the power consumption. So in this case, you can see power consumption. The green line is the average power consumption per hour, and in the blue line is represent the 19th quintile of the same metric, so the power consumption in watt. It's interesting to see that in this case, and you can see already that the behavior and the analysis has more or less the same pattern that the CPU utilization. We will see in a few seconds better. Okay, so this means that the correlation is reality is valid. Okay, as the model as I showed during the presentation. So. And then we can integrate this data and we can correlate this data not only with the data about carbon emission, but we can use also performance data to generate recommendations. So in this case, you see 3 different levels of performance metrics that we are considering. One is the CPU utilization, the memory utilization, and the storage utilization. So the first thing that you can see is that the recommendation is a good recommendation, because at the end, if you see the CPU at the 95 percentile, you see that we don't consume more than 30%. So the recommendation to reduce from 4 to 2 CPU is still valid. And also for the memory utilization, we can do the same. We have the same perception, because we are not using. We are using more or less the 43% of the memory, and in the recommendation, they are cutting memory passing from 16 gigabyte to 8 gigabyte, and the same for the storage. So this is just to give you evidence about that the recommendation is good, and this helps also you to reduce the carbon footprint and the electricity consumption. So another interesting thing that I want to show you, so if you see here the behavior, we have more or less the same pattern also in the CPU utilization. So this is also another interesting thing that is validating the model and the correlation between the power consumption and the CPU utilization. So with this, I concluded my presentation. We will start the Q&A session. Over to you, Samantha.
Yeah, no worries. Let me just unmute everyone. So Ahmed had a question. Is this great dashboard available in the marketplace for BMC? And Ahmed, feel free to come off mute. I'm just unmuting you to speak live with us. Can you hear us, Ahmed? I don't know if he wants to talk, but just in case, if you could answer that question, Michelangelo, someone in the Q&A just he was asking, is it available in the marketplace, the dashboard?
Oh, no, it's not yet available in the marketplace, but we have a roadmap, and we want to try to make available these dashboards in the next release of the Helix continuous optimization.
Thank you for answering that. I don't know, Ahmed, if you had any other further questions, again, feel free to come off mute or put them in the Q&A. Don't have any other questions at the moment, so while we're waiting to see if anyone's got questions, Michelangelo, I don't know if you want to summarize some of the questions that came up this morning that were very interesting ones that might be quite useful for the customers that have attended today.
Yeah, so today morning was a really great session. And so just I want to say we had two customers, and they started their initiative ESG, and they are facing a lot of issues regarding to how they can approach to this topic. So basically, they share with us that the big problem that they have is one in the collection of the data. And we can help on this because we can collect performance data directly from your environment using out-of-the-box connector, and we can integrate all the others data directly from the tools that you have in your data center. And if you don't have these same tools, we can also estimate the power consumption. Also in this example, part of the data has been derived using the model and the correlation between CPU and power consumption. So this customer was really impressive about the capabilities of the solution to ingest the data from different data sources, obviously also from the energy maps, and to calculate and estimate the carbon footprint. Another big important things that today we discuss with these two customers is about how we can use in a better way the electricity maps, because we know that we have different in the same country. Probably we have different zone with different kind of carbon emission that we have to consider. And I explained that the carbon maps, the electricity maps, can be also used and can provide you more detailed information, also splitting the carbon emission in the same country with different zones. And for instance, I don't know, we have in Europe different zone in the same country. So usually each country is divided in the north, center, and south, and for each of this zone is available the carbon density value. And then one of the other part of the discussion that we had with these two customers was about the benefit and the experience that we have about the benefit that we can bring using an approach that using the capacity management process is able to drive also this kind of initiative. So, and on average, our customer managed to optimize the 30% more or less of their infrastructure by adopting the solution. And usually this translates into an 8 or 10% in energy consumption, in reduction of the energy consumption and CO2 emission. So this is a big result for the company. And at the end, the first part of the journey to the ESG sustainability program start from the IT operation, because it's not easier, but is the most part of the company that bring more value. Because at the end, if you are able to optimize your infrastructure, you are able to consume less energy, and then the end, you are directly reducing your carbon footprint. So that's the reason why IT operation are the first part of the company that are used to investigate this topic. So those are all the topics that we had. Another important question that I got this morning is about the resources that we can integrate in the model and which other information we can integrate. Okay, so starting from the resources, in this case, I show you what we did only for the servers, but we also produce some reporting for the network devices and also for the storage box. It's more complex, let me say, but we have techniques that we can adopt. In this case, for instance, for the storage, we analyze the power consumption at the storage box level, and we can consider the usage of the storage, trying to break down the carbon emission, not at virtual machine level, but at cluster or ESX or physical server. So for the network is the same. So where is possible, we are able to break down the part that is used from an application and a business service, and we can try to split the consumption and the carbon emission by application and business service. And regarding what other information we can import in the model, we have seen that we can also import other kind of information. Obviously, for the scope, about the ESG scope, it's important to import data about performance, electricity map, and carbon footprint, carbon emission, electricity consumption. But we can also import other kind of information, like information about the scope 3 that represent, as I told you during the solution demo, that represent the carbon emission related to the supply chain and the disposal of the resources. Or otherwise, we can import also other important things about, I don't know, the carbon footprint emission due to the cooling of the data center, or we can ingest also the information about the PUE, the power usage effectiveness. All this information can be included in the model that we can easily create in the Helix continuous optimization in order to refine the results and try to estimate in a better way the carbon emission and the carbon footprint. Yeah. So I don't know if I lost something, Samantha, so please help me.
No. Thank you. I think you've covered it very well. I did see also we have got another question that came in. It was actually on the chat rather than the Q&A. And apologies, I should have been clearer. Just the Q&A. We tried to download them after, but I've just made note of your question, Pablo. So Pablo's question to us was, can we estimate the savings in CO2 emissions when a customer migrates VMs from on-prem to SaaS?
The on-prem in the cloud, you mean? Yeah, so in this case, we can compare the different speccing that we can produce based on the carbon emission. So like we did for the performance, we can do the same exercise considering the carbon emission data sheet, okay? So we know that we have different carbon emission when we migrate something from the on-premise to the cloud. And the carbon emission of resources in the cloud change depending from the region and from the instance type that you choose. For this reason, if you are able to optimize the on-premise resource, you can bring value not only in cost saving because you can right sizing your instance, but also in the carbon footprint. For the cloud provider usually don't provide information about carbon emission, but we can collect this data from other companies that work with the cloud provider in order to certify their data center and provide public speakings that can be used in order to evaluate the benefit to migrate something from the on-premise to the cloud. So usually we already do this using performance metrics, but we can do the same using also the spec int information about the carbon emission datasheet. Yeah.
Thank you. Pablo, I can see you've come off mute. Did that answer your question?
No, it's only to agree with Michelangelo that sometimes it's also good because I know we are able to provide savings from migrating VMs from on-prem to cloud, but at the same time, this would be great, and I see that it's possible to provide information about the savings in emissions, and this is great to know. Thank you.
Thank you, Pablo.
Yeah, thank you for your question. Okay, that's all our questions we've got so far. I don't know if anyone else is brave enough that want to come off mute and ask Michelangelo a question. It's a great opportunity to share some insights and let us know how you're getting on. If not, I'll give it a minute or so, Michelangelo, and then we'll close down the call.
I don't see other question in the chat, Samantha.
Just having a look on the Q&A. I think everything's been answered prior. Okay.